In IPv4, this is the Internet Protocol version 4. We have 5 classes: class A, class B, class C, class D, class E. Now this first class, class A address, because IPv4 has an addressing scheme. Because this is a 32-bit address, all depends on the 4 octets. 32 bits, that means we have 32 1 and zeros, but they are separated by dots. So we have this 8-bit, then 8-bit, then 8-bit, then 8-bit, and they are separated by dots. This 8 into 4 becomes 32. So if you take the first 8-bit, or you can call that, you can say that from the left if we start, if the first bit of this 8-bit chunk, that is the group, the first bit, if it is fixed as 0, if the first bit of this whole IPv4 address is fixed as 0, then this type of, these numbers being formed are called as class A address. They will fall in class A address. For example, the first number will be 00000001 because 0 is fixed. What is the decimal value of this? 1. What is the highest? 0 is fixed. So the highest can be 1, 1, all ones then. This is the highest one. What is the decimal value of this bit formation? 127. So 1 to 127, if the first, in the IPv4, the first number, that is the decimal dotted number, the first number, if it is between 1 to 127, then you can safely say that this address is belonging to class A address. Once this 0 is fixed, the other 7 bits, these are network address. Because every IP is having a network address also and host address also. So the bit which we have fixed, there are 7 bits remaining. These 7 bits are network address. Already? Now, once this 8-bit one is fixed, 7 bits are for network address. How many bits are remaining? 32. 8 we have already done. So the remaining are 24 bits. These 24 bits are for the host address. Please remember the IP is uniquely identifying your system on a network or on in the universe actually. So how many networks can be formed, or how many networks it can cater? 2 to the power 7. The formula can be seen here. And how many hosts per network? That is, these many networks can be there, and these many people, these many gadgets can be there inside one network. So it can be 2 to the power 24. This is from network. From here to here, it is for the host per network. 2 to the power 24. This is class A address. Okay. What is the range then? As I indicated earlier, the minimum can be 00000 and 127. The highest can be 255, 255, 255, because each octet can have a maximum of 2 to the power 8 minus 1. That is 2 actually 2 to the power 8 is 256. So it comes down to minus 1. So 255 can be higher because we start from 0. So this octet 1 to 127. So the first one I am showing, 0 is fixed. All NNNN are the network bits and HHH are the host bits. But if I say you 1 to 126 only we can use. You'll say, you just said that it can go from 1 to 127. Why it is 126? Why you are not taking 127 also? The answer is, this 127 is reserved for loopback IP address. That is, normally if you go to your browser and type 127.0.0.1, that is, this is the range. The range is from 127.0.0.0 to 127.255, 255, 255. But these all are wasted. Only one is used. And that is for your loopback address. Whenever you ping or on browser you put, that is actually you are testing your network interface card. Okay. So your packet is not leaving your computer or your system. It is coming back. It is looping back just in order to see if the TCP IP is correct or your NIC card is perfectly fine or not, properly connected or not. Alright. So this is 127 is used only for loopback addresses. That is why only class A can go from 1 to 126, the first octet. So the address class A or any address is having a network address and host address. Now, how are you going to find out which one is the network address and which one is the host address? The default subnet mask or the subnet mask is used to identify which is the network bits and which are the host bit. For example, if you add this number with 255.0.0.0, 255 is all ones. So that will come out, the first octet will come out as it is, and that as it is actually the network address. That is how many networks we can have. If you have a very large network, this class A address is used, for example, for big organization. An example for class A address can be, let us have 10.50.120.7. Now, how will you say that this is a class A address? Why it is class A address? The answer is, we have to see the first octet. The first octet should belong from 1 to 127. Actually, not 127, it should be 1 to 126. 127 is used for the loopback. So the first octet we are talking about, it can range from 1 to 126, as I said. Alright. So just see the first octet. This 10, when you see, oh, it is between 1 to 127. So this is a class A address. 127 we don't assign, as I just indicated earlier. We just see from 1 to 126. The first octet is 10, so it is belonging to class A address. And the other part, which is 10.120.7, is what? It is a host address. So there can be multiple network that is decided by 10, and 50.1.120.7 is deciding what is the host, what is the computer, what is the tablet inside that particular network. So if you have two devices or multiple devices, if they are on the same network, the first number of the IP address starting from the left or the leftmost bit combination, which is whatever combination decimal it becomes, it has to be between 1 to 126. So if I write a number 10.47.8.4, the first number is 10, the second of the both IPs. That means these two IPs are of the host of the same network, similar network. Don't worry about the next three octets. If I write 11.5.4.3, if we see the first octet, first decimal number, one is 10, one is 11. So this 11.5.4.3 is not belonging to the same network as 10.50.120.7. Okay. So if 10.1 is this in this network, 11 will be in some other network.